I mentioned sometimes that all you need to do tool grinding for the most part in a machine shop is a surface grinder, not a tool and cutter grinder. And furthermore, I said that in many cases you can use a milling machine to do tool grinding. And well, somebody challenged me on this and asked me to show a setup for sharpening machine reamers on the surface grinder. And the exactly same setup can be transferred one-to-one over to a milling machine with one little modification. But I will get into that. Generally, when I build setups like this, I just walk through the shop and bolt things together until I get somewhere. In this case, we are grinding a machine reamer. Machine reamer has centers on both sides. So best thing would be to hold it between centers for grinding. And I'm in the lucky situation that I have a set of centers, for the surface grinder. I built this years ago to do cylindrical grinding on the surface grinder. I have a video on building and using it somewhere here on YouTube. And this allows me to hold the reamers between center very nicely. One of the centers is spring-loaded, so you can put your work between centers without moving it and keep constant pressure on it. If you don't have a set of centers like this, well, build a set. They are super useful for all sorts of indexing, spinning, and inspecting parts. Or you can use, for example, there are fixed center sets for inspection. They show often up on YouTube for inspecting round parts, and you could use something like that too for this purpose. So we have our work held. Now we need to index it, because in this case the reamer has 6 flutes and we need to index it in somehow. Little tidbit to know, most half-decent modern machine reamers do not have an even spacing between their flutes. They are irregular spaced. So you have to use an indexing finger against the flute or the cutting edge that you're grinding. In this case, my index finger is a steel scale held with a large washer to the base of the center set, and the end of the, and I get the reamer out, and the end of the scale is just resting against the flute, which corresponds to the cutting edge that I'm pretending to grind. That means I can index my cutter like this, and when I rotate it against the finger, it indexes very precisely. And that's basically the entire setup. The only thing that you need to do then is you put an indicator on the edge or on the surface that you want to regrind. Indicate it true to the machine travel by moving the index finger in and out. An ingenious person would build some kind of a fine adjustment like I have on my real tool and cutter grinder. But if you do this only once or twice a year, you can get around by just bumping it in place. Then you lock it in place with the screw and you're good to grind. Touch off with a grinding wheel on top of the facet that you're regrinding, and you're good to go. Let's look into geometry of a reamer, machine reamer. Okay, we have a machine reamer here, and up here is a sketch of the reamer. Back here is the shank. That's to hold it in the machine. And we have a necked down section here. This is just to make the reamer longer and give it a chance to work on deeper holes without creating a horrendous amount of friction. Then we have the cutting end here, which has basically two parts. We have a very long cylindrical part, which is not truly cylindrical. It's backed off a few microns to the towards the shank, so it doesn't bind up in a bore. And we have a 45-degree chamfer section in front here. The 45-degree chamfer does the majority of the material removal when you use a reamer in a bore. This is what cuts the material away, and the cylindrical section smooths out any remaining surface roughness and also defines the cutting diameter of the reamer. Apart from that, this portion here doesn't do much. And also it's kind of guiding the reamer once it's started in the bore. So it's kind of averaging out if a hole is not pre-drilled 1000% straight. There is very much a limit to how much a reamer will straighten out, but a little bit it will straighten out. There are end reamers, which is basically an end mill that's made to bore, and those are made to straighten out bores and create a very precise hole location, but not these. These will, in the beginning, very much align to the pre-drilled hole, especially since they are very long and slender diameter. But once you're started, it kind of averages out if the bore is a little bit bent or crooked, within reason. So back to Reamer. So the cylindrical portion is ground like a little bit cylindrical, and then it's backed off like this. And then you have the 45-degree part in front here, which does the cutting. To repeat myself. And that's the only part of a reamer that we generally regrind. 45-degree chamfer in front here. If possible, we do not touch the cylindrical and backed off part here. This, apart from when we want to resize the reamer, when we want a reamer to cut a different diameter, we have to put it on a cylindrical grinder and grind the OD of the flutes to the new diameter. Then we have also to grind a relief behind the cutting edge. There are two types of reamers. Let's see, we have a reamer and let's say we have one tooth here. So this is the one tooth. Some of them have a little bit of a cylindrical section and then are backed off very dramatically. This is what we have on these modern machine reamers. But there are also reamers, let's see. Where the back off is, they are not backed off. They are completely cylindrical ground, and these will create a lot of friction in the bore. You can do this to a reamer if you have to, well, ream one hole in a material that's very easy to machine. But generally you do not want a fully cylindrical ground reamer because it will create all sorts of trouble. So this is an excellent set of sketches, I have to say. Oh God, oh yeah, I see, yeah, ignore that. So don't touch the cylindrical part if you don't have to. So you can resize reamers to a very small amount with a lap, with an outside lap. Something like this. You put it over the reamer, put a toolmaker's clamp on it, add some lapping compound, and you put some drag on it. Then you spin the reamer backwards and you lap the OD. That's one possibility to get a reamer to cut 10 or 20 microns smaller. That's absolutely possible. And you will end up with a little bit of a larger land. That's the cylindrical ground portion of the cutting edges or flutes, but they will still work. They are backed off very to a large degree, so you have a little bit material to play with. To circle back, we prefer to not touch these flutes at all. We only grind, in this case it's a 6-flute Reamer, we only grind these facets. And they are super simple to grind. They are at a 45-degree angle and they are just flat. There is no curvature to them, there is no weird back taper to them. They are just flat with a back, with an angle to the back, so they clear the material. Using a dial test indicator on the clearance surface of the Reamer to indicate it true to the machine travel. And indicating such small surfaces is not easy, but absolutely doable. As you can see, when I traverse back and forth, up here on the indicator, you see a sudden rise. That's when I get the ball of the indicator onto the surface. Then it stays constant for about 1 millimeter of length. That's this area here. And here it's dropping off again. So this is reasonably well indicated. And I indicated it by moving the scale that I use for an indexing finger back and forth. Cleaned up all the cutting edges here on the surface grinder. I used an 80 grit aluminum oxide wheel. This is a ceramic wheel, Norton 3SG wheel. Little bit better than your regular aluminum oxide wheel, but behaves very similar. So I mentioned that we could do this grinding operation on milling machine too, and that's true. Only thing that you need is a cup wheel, either a straight cup wheel like this one or a tapered one like this. These are both aluminum oxide 80 grit. I think this one is a Norton. And you put this in the spindle of the mill, you use a diamond down here to dress it. Take precautions for dust extraction and protect all the ways of the machine. Otherwise the abrasive grit will get everywhere and eat up your machine. And then you can use this to grind your surface here, just by traversing over the Reamer's cutting edge here. So the entire setup can be taken with the vise here over to the mill and I could do the grinding, but use your creativity to your advantage when you have to do something like this on your machine tools. I think all that's left to be done is to do a test cut with this Reamer. I have a piece of stainless steel here to do a test cut. This is a spotting drill. Let's see. Let's don't waste a ton of material, so we go to the outside here. Clamping it in place using Copal clamp. Since this is stainless, it's 14305, relatively free machining material. We don't go crazy fast. Spot drill. 3mm pre-drill. This can go faster. Ran it at 3000 RPM. Now we follow up with a 5.9mm drill. This is the pre-drill for the Reamer, giving us 0.1 millimeters allowance in diameter for the Reamer. This will go slower, running it at 1000 RPM. I also drilled through the sacrificial plate to give me clearance for the Reamer. Countersink, because it's good practice to put a countersink on a board that you want to ream to give the Reamer an idea where he has to start. That was a very generous chamfer. Running at 180 RPM using water-soluble coolant as a lubricant. You can influence the diameter or the behavior of a Reamer with your lubricants. Something lighter, like water-soluble oil, will usually create a tighter tolerance or tighter dimension hole, and oil will make the Reamer cut usually a little bit bigger. Okay, I have the correct gauge pin here. 0 on this side, this is the go side, this has to go in the bore, and this is plus 12 microns, this is the no-go side. This cannot go into the bore, otherwise this is not a 6H7 toleranced hole anymore. So the 0 side, oh yeah, this goes in very snug, very tight, but it goes in without binding up. And the no-go side, well, doesn't even want to start. I could force it in a little bit and create a press fit, but this is as well within tolerance. Running the Reamer with cutting oil would probably yield a mildly bigger bore, but still be very much in tolerance. But often when you want to do a press fit for a dowel pin, this is more in the realm of what you want to achieve. If you want to be very particular, you can tune the Reamer a little bit by chamfering or rounding over the transition between the 45-degree chamfer and the cylindrical part here with a ruby stone. And you can also, if you're out in the desert and you need to ream a bore that's like, you have a 6mm Reamer, but you need a 5.99mm hole, you can alter the diameter of a Reamer with a piece of carbide to burnish it down. Very much like you would burnish the cutting edge of a card scraper for woodworking. You just take it and you burnish the cutting edge down, and this will decrease its size ever so slightly. You can do that the other way too. You can go on the inside of the cutting edge like this and burnish and raise a burr and make the Reamer cut for 1 or 2 holes bigger than it should. But that's very bad for the Reamer. It's damaging the Reamer. It's kind of a, well, we have nothing else solution, but good to know that it's possible. But now that I told you that it's possible, never use it. So that's Reamer sharpening on the surface grinder or on the mill if you want. So that was resharpening or grinding a machine Reamer with shop available fixtures and tooling. Of course, not everybody has a surface grinder and a set of centers, but as I said, it's fairly simple to rig something up with 2 centers at a fixed position. The precision requirement for a center fixture is relatively low as long as you make it adjustable, or if you hold it in a machine vise, you can just tram it in as necessary. So I think that's a reasonable approach for most shops. And if you're willing to spend some time and use the milling machine as a tool and cutter grinder, which you absolutely can do, there is also the option to go for a super abrasive wheel like a CBN wheel for steel or diamond for carbide, and you reduce the amount of abrasive grit that ends up in your shop and on the machine tool by a large amount, because those wheels don't need as much dressing and redressing as an aluminum oxide wheel needs. So that's maybe even more of an idea to consider. So I hope you enjoyed. Thank you all for watching, and I'll be back.